Hi guys, let's start example 1, which is on graphing relations and their inverse relation. So the first step, we're going to start with our original relation, which remember from the Prezi, a relation is just a set of points. So we're going to start with our relation, and the first thing we're going to do is going to graph our relation, or graph the points. Okay, and I'm going to number these points so I remember which order I went in. This is going to be very important. The order that we go in to graph these is very important. Okay, so the very first point is at negative 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so about right here. Alright, so there's my first point. Alright, my next point is going to be at 1, negative 3. So 1, negative 3. And I'm going to connect them as I go. So I went from 1 to 2. And then I'm going to graph point 3, which is at 8, negative 5. So 1, 2, 3, 4, 5, 6, 7, 8, and then down 5. So 1, 2, 3, 4, 5. So about right there. Yes, about right there. Alright, and I'm going to connect from point 2 to point 3. So it's kind of going to look like a crooked line. So this is my relation, and I don't put arrows on the end because these are all the points I have. The graph does not continue on, it's only those 3 points. So that is my wonderful relation, and then we're going to be finding the domain and the range. So domain. Okay, domain, if you remember, we always ask ourselves how far left and how far right we go because domain involves the x values. Well, the only x values that I have in this relation are these right here. Negative 9, 1, and 8. Those are the only x's in this relation. So my domain is only going to be those 3 points. So my domain is going to be a set, and I'm just going to list the 3 values that are in the domain. And I usually like to list them in order from the smallest number to the largest, but it really doesn't matter the order you list them in. So my domain is negative 9, then 1, and then 8. And again, all those are my x values. Okay, so these are just my x values right here. I'm sorry, and this should have been a curly brace. Like that. Sorry, my curly brace should have been more like this. I apologize. So my domain are the values negative 9, 1, and 8. Those are all the x values. So all my x values were my domain. And then my range, remember when we find the range, you ask yourselves how high does the graph go and how low does the graph go. And we do that because range pertains to the y-axis. So my range, we're going to be listing all the y values. So now we're focusing on our y's. And we're only going to list the values that are the y values because those are the only y values on the graph. So we have 10, we have negative 3, and we have negative 5. Which again, you can list them in order or you don't have to. That's up to you. Alright, so our relation is all done. So now we're going to be moving on to our inverse relation. So if you remember from the Prezi video, all an inverse relation is when the x and y interchange. That's the fancy word we'll be using quite a bit when we talk about inverse relations and functions. So interchange, all that means are my x and my y values are just going to trade places. Okay, so like my negative 9 is going to hop to where the 10 is, and the 10 is going to hop to where the negative 9 is. Okay, none of my signs change, so be careful. Our signs do not change when we find the inverse or when we interchange our x and y values. So my inverse points, it's in a set, so I'm going to draw my curly braces. All I'm going to do is list these 3 points, but my x and my y values are going to trade spots. It's going to be awesome. So my first one, if they trade spots, would be 10, negative 9. My next one would be negative 3, 1. And my last point would be negative 5, 8. So all I did, my x and my y values just traded spots, just like that. Alright, so now we're going to graph these points, and I'm going to graph them in the same order that we did up here. So since I graphed the -9, 10 first, I'm going to graph the point that relates to that one first. So 10, -9. So that's the first one I'm going to graph. So 10, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So about right there. That's my first point. And then my second point, the one that pertains to the second one that I graphed earlier. Okay, so my second one is going to be the -3, 1, because the second point I graphed earlier was 1, -3. So point number 2 is at -3, 1. So 1, 2, 3, 1. Alright, I'm going to go ahead and connect those. We connect them in the same order that we originally plotted them in. Alright, and then my final point is at -5, 8. So 1, 2, 3, 4, 5. And then up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So about right there. Okay. So again, it kind of looks like a crooked line again. Holy hot dog. Alright, so the purple graph is my inverse relation plotted, and the pink one is the original relation plotted. Now domain and range. Again, domain, they're just the x values. So again, these are just the x values in my relation. Whoop. Sorry about that. X values. So my x values are 10, -3, and -5. So these are my 3 x's currently. So 10. Sorry guys, I don't know what I'm doing today. 10, good golly. 10, -3, and -5. Alright, and then the range, same idea. Okay, but now we're looking at just the y values, just the y values. So we have -9, 1, and 8. So that would be the range of my inverse relation. Now, something we're going to be pointing out. If you look at the domain and range of the original and the domain and range of the inverse, which I'm going to write them down here so you guys can kind of see both of them side by side. So the domain of the original was -9, 1, and 8. And the range of the original was 10, -3, -5. Now looking at the domain and range of the inverse versus the original, I wonder if you guys notice anything special about these. Well, if you notice, the domain is the same thing as the range. So the domain in the inverse is the same as the range in the original, and the range of the inverse is the same as the domain in the original. So what has happened? Not only do our x and y values interchange from the original to the inverse, also the domain and range will also interchange. Holy hot dog, right? Okay, so your domain from the original will always become the range of the inverse. Okay, and the range of the original will always become the domain of the inverse. So the points interchange as well as the domain and range, and that will happen every single time. So technically, when I found the domain and range here, I could have already predicted what the domain and range was going to be for my inverse before I even plotted it. Holy hot dog, right? Alright, so that is our first example problem. I had a blast.